So in this demonstration, we would like to show how to do an equivalent to like a motion page tool with the Robotics IDE. This OpenCM IDE version 1.02 here. So let's first do a quick review. By now, you know that this is a page, like fast forward page, motion page. Each page can have up to 7 steps. So, and each step is really a set of goal position of all the servo that you use. So this is humanoid, so it have 18 servo. And let's leave it down here. So for the application we have in Robotics IDE, we have to simplify things. So this is a CarBot. Normally, of course, AX12. Normally we use it as in wheel mode. But in this example, I already set these guys into position control mode. So this is 1, and then 2 over this side, 3 over here, and then 4 here. And as far as controller goes, I have an OpenCM 904B. It sits on top of the 4085 EXP expansion board. So the servo are connected to the 4085 EXP board. So as far as I'm concerned, 4085 EXP port is serial 3 COM port as far as the OpenCM 904B is concerned. We also use serial 2 of the 904B for Zigbee connection here, okay? And the power is a LiPo 11 volt. It hooks up directly into the 45 XP board. So when you turn it on, it also power a CPU board per se, the 904B. Okay. First, the code, the INO file, the sketch file called QMotion page play. This one is the one that modified by myself to make it a little bit easier to explain things. Actually, I came it from their example. So if you go to their example, dynamic soap. So this is the one, the optional one. So you can have that if you have installed the Robotics IDE, you can have that, the optional one. Mine is modified a little bit. Let me show you what I have modified. First, I want to use the RC controller, the actual virtual controller from the PC, really. And we'll get to that. So, and I plan to use it from the RoboPlus manager. Like, for example, here is COM8 for that Zigbee, BT10. So I plan to use this one. But there's no power on, so we'll have to wait for a little bit later. Okay, come to that. Let's go through the code. I will try to explain some of the basic steps. So in order to use the RC controller, you need to include, and then you call the device, or define an RC100 object and call it controller. There's a few parameters defined. I use 4 actuator, and the ID 1, 2, 3, 4. Dynamic cell bus, you can see it's 3 serial port. One is when it's whatever is connected to the OpenCM 904B board itself. 2 is for LNO1, BT210, Zigbee, and all of that, and that's this guy here. Okay. And then serial 3 is connected to the 485 EXP board. Declare a few array, word data type, goal position. So you see that the element have 4 elements. So basically for each actuator, there's a goal position. Something called previous goal position is used to compute how to go from one goal position to the next. ID, array. The right goal position array, that one is for the sing right function coming up. Because I'm sending data from the virtual controller, RC100. So I have a data variable for it, a parameter for it. They also designed something called sing page, where they're going to put data in here, basically the goal position for that servo for it to go through. And then because all my dynamics are hooked up to the 485 DXP board, and that's on bus serial 3, so I define a dynamics object I call DXL, and I had to use serial 3 here because all my AX12 is on the 485 AXP board. I also define some other constant like goal speed, goal position. So these are coming from the control table on their website. So basically address 32 for goal speed, address 30 for goal position. And then we get to the setup. Good old Arduino setup here. Initialize I0. Have to go to dynamic speed on the bus. 1 megabit per second. Because this is dealing with AX12 servo. The DXL packet type 1. So define that. And then send the join mode command to each of the servo to make them to go to join mode. One thing important, watch out. I tried this code before and didn't seem to work too well. You may have to set up from the manager tool directly to be more reliable. So this command is kind of flaky for me. Maybe because it had to go out onto serial 3 or something. I haven't got time to check on that very carefully. And then I set the goal speed to 512 for each of them. So which is kind of a medium speed. Okay. And then you initialize the controller essentially. And then I use the write word, that means ID number, goal position. Essentially each command here tells each servo 1, 2, 3, 4 to go to 512. And then give it a second, don't do anything to get them to get a chance to get there. That reminds me, when I power it off now, so I'm going to turn them off to have different location in the store. But then when we initialize, there's certain action we want to see. Also initialize the W goal position array, 512. Also now the previous goal position array, the many array you see in this tool. Delay a second just to have things settled out. And then because remember we have ID 1 through 4, so there's a little for loop to set up the compliance of the slope, which is address 28 for the clockwise compliance slope, address 29 is the counterclockwise compliance slope. So these come from the control table available on the web. So I want to use 64 for them. And then it trigger motion page 1 and then trigger motion page 2. And what are those guys? They're down here. So motion page 1 essentially define each of the goal position for the 4 servo, the whole 512, and then the trigger motion page plate, which is a function. I will get to it. Basically, say, oh, use this array W goal position. 700 is a time to, let's see, the time to do it in milliseconds. So basically, you need to go 512 within 700 milliseconds, and then but it wait all the time between pages is 200 milliseconds here. So that's motion page 1. You see everything 512. Motion page 2, servo 1 and 2 is still spaced at 512, but servo 3 and 4 got changed a little bit, and like that. So essentially, when I turn on the computer, in the robot, it will do setup one time, right? So you see wherever they are, it's gonna trigger page 512. Page 1, which is everything to 512, and then it change 3 and 4 a little bit. So that's kind of the initial one to do. Well, let's see. Let's try it now, right now, and see. So you notice the power is on. You see where I are. I'm gonna turn it on. I'm gonna trigger the code that I already downloaded on it right away. See it go 512. And then 3 and 4 got changed a little bit, okay? So you just see this side here. So let me change this side so you can verify it. 512. Okay. See, 1 and 2 stay 512, but change a little bit here. Let me change a little bit here. Okay. Just to see, let you see. So it just did a setup one time. And then go into the big loop, Roy loop. If the controller available, that means I send over some data, and then it pick up the data, put into the receive data parameter, and then it check. If I push the U button, it does motion page 3, 4, 5, 6, 7, 8. Okay. If I push D button, it pay motion 1. That means everybody 5, 12. And just wait. If I don't push anything or don't do anything else, it just do nothing. It stay whatever happened to be. So it could be that it's finished after the up button push. Maybe it finished after the D button push. All right. Everything we learned on this motion page play. And here, well, whoever created this called page, but if you go back, it's really pose. So this function should really say motion pose play and not page play. So what it does is pick up a pointer to the array W goal position. You need to tell how long you want to go to, how long did it take to go to that goal position, and then the pause time. So the pause time, so if you remember this in motion 1, so the pause time is this array, the time to do something in this array. So this one here have no pause, but have some time to do it. Let's see. Okay, like for example, init here already have a time to go to that pose and also a pause time. And this is showing you that the pause time happened first. Okay, and then whatever the time you tell to do to go to this goal position, it divide by 8. And this is important. Later in chapter 11, you find out that the way robotics software or firmware implemented all the position goal is it updates their goal position every 8 milliseconds. That's where that 8 comes from. So from the time mill here, you divide by 8, you get the number of steps. In initial W count, they're going to go and then initialize I and II, that sort of thing. Go from start from 1. Also, create a W10 goal position, which I'm not sure if we use anywhere. I didn't see use anywhere here. Okay, so remember, so every 8 milliseconds, there's an update of the servo. You can see there, that's why it computed the number of steps. And then it has a big loop outside from W count goes 0 to strictly that number of steps. So this big loop out here is executed the number of intermediate step of position. Next, it needs to compute the new goal position to go to from wherever it was. So it goes from 0 to essentially less than 4 because we have 4 actuator, then go 1 by 1. So if you remember the goal position, everybody go what? 0, 2023 for an AX12. So if the goal position we're supposed to go to, the W goal we're supposed to write into it is bigger than where it is, obviously you need to update it. So where you are, where you're supposed to go, minus where you are, subtract it, rubber count, divide number of steps. So it'll tell you the kind of goal position in between. This is laying out, if you think of it as a timeline, and it figure out the goal position where it's supposed to go. Yeah, every 8 milliseconds. If W goal position less or equal previous goal, obviously you're gonna trigger else, and then you can see it's subtracting from it. That kind of the idea. And then because if you send each of these goal position one by one to each servo, it's kind of inefficient. So the robotics people designed a so-called sync write. So you send all of these things one packet, zoom out real fast. So they're setting it up here. Okay. It's used 65 times and it's skipped by 2. So if you remember the sync page, where did it go? Yeah. Have the servo ID and then 0. These are the numbers should go into it. to prepare the sync page. So prepare the sync page. 1, so basically from 1, we could jump by 2, so 1. So that if 1 here, that's the second element. You can see it go jump by 2. Okay, so it go what? 1, 3, 5, 7, and then 9 to do it here. So once it's done that, the sync page is prepared. And then they use the sync write to do it. And let me see, the sync write, you have to dig in really the deep source code for it. And they have this function, sync write, and you can see start address. And you can see because we are trying to update the goal position, so you hit address 30. And then data length, 1. Word parameter, that's the array of the data actually. Sync page 1, that we just prepared. 8 is say some kind of parameter length. And so this is the code here, dynamics.cpp, if you want to go into the gory detail of that. So once I've done that, it sent out a big packet with all the data for the sync page. And then the firmware on each server will take care of that part. And then because you are there, you need to update whatever you have to go to. Supposedly by that time, it will arrive at the new goal position. And you update your previous goal position array with it, delay 0.1 of a second. Take it, you let it go. Okay. So you remember each of the motion pages essentially have the W goal position all defined. Yeah. 4, 5, 6, 7, 8. They call pages, but it's really position or steps. And then you trigger that function. Is it time to do it? Is it the pause time? And this is your array that have all the data. So it pumps lots of data through that to the bus. Okay. So let's see how to play with it. So let me turn it on. Okay, you remember it go 512, 512, and then you're going to change it a little bit here. So right now I haven't not connected yet. So it's still blinking here. So let me bring it in. I'm using Bluetooth, so COM8 is the outgoing port. And I highlight it, and I use the ZIG to serial management. Take some time. Okay. If it shows this, we're in good shape. You put it here, and then I click on the R3 900. It create me this icon. Let me make sure everything is in and recorded. So now I'm ready to do it. So if I push U, okay. So it play all those pages. So let me show you the 1 and 3 phase. So it goes through all these position pages, and you can see I manipulate this and that. Okay. So now, and you notice every time I push U, actually it's a bunch of 1 I send away. So if I push D now, everybody go to 512. Okay. And let me push up one time, but it's actually quite a bit. PC is fast. And then you see it go through all those so-called 3, 4, 5, 6, 7, 8. So what, 6 pages, and whatever each page is, all you can see it. Okay. The thing is interesting because it's sent several times. It may just do this page several times because right now in the code, there's no way you can tell whether someone just want to do it one time or many times. Because as fast as I can kick it, oh, okay, I'm just push it on the keyboard here. So I push it only one time. I actually send, you notice I send only one time. Oh, even that fast, it sent twice. So we'll see if it catch the second one being the second command or not. Now let me try to see if I can send 2 real quick, down real quick. Push the arrow down. Okay, even that fast, I have 2 of them already there. Okay, so that basically the basic idea of creating a motion page on it in about this IDE. So let me clear all that. So you can see lots of work, lots of detail, and all that. And if you remember, it will be tough. Remember how tough it is here to hook up the robot to define all the position and the poses. And it's because of this nice interface that we could make very sophisticated motion pages in step, like this one. So, okay. So, but here, that's the bare bone, the nuts and bolts of how to make it go through from poses to poses. It's a big challenge, isn't it? All right.